This question has a strategic approach. We could definitely arithmetize here because we have values for x and y, or we have x and y's that don't have values, and so we can make them up and kind of understand what's going on. I will show you that method at the end, but the best way, the most efficient way to do this is definitely just to understand the algebra. So maybe just looking at the original equation here, you might not know what to do. And I understand that, because to me, that kind of looks like it's in simplest form. If I was given that, I wouldn't naturally change it. But obviously the question is asking us to change it. And this is why it's good to remember that this is multiple choice. Like, let the choices give you information, just like the question gives you information. It should be clear from the choices that they're kind of asking you to factor something out, right? To pull stuff out. And that's kind of maybe the opposite of distribution, right? And so if you look at the choices, you might say, okay, well, if I were given these, I would distribute the 5x or 5x squared back in. And you can still do that. You can kind of guess and check this thing if you want. But factoring is an important enough skill that we should really know how to do it. So what we're doing here is called GCF factoring. What is the greatest common factor? What is the biggest number that divides into both of these pieces? Well, I see that a 5 can come out of the first one, obviously, and 50 is also divisible by 5. So that means 5 is going to come out as well. And look, the choices tell me that. I didn't really have to know that. So the real question is, can I pull out just 1x or 2? And the reason I can only pull out 1 is this first term has 2 x's, right? X times x. But this second term, the exponent that is on the y only applies to the y. The x has its own exponent of just 1. So this is 1x. So that's the most number of x's we can pull out, because even though the first term has 2, the second term only has 1. So we'd run out of x's if we tried any more. So that means 5x is going to come out. And now we have to think of it like a division problem. Okay, if I took 1x out of the first term, I'd have 1x left. And just think about it. What would 5x times x be? That would be 5x squared. So there you go. That's what we have in the original. And then if we divide 50 by 5, we'd be left with 10. And then if we divided out the x's would be gone, right? The 1x would come out. And the y squareds, though, they would just kind of linger behind. They have nowhere to go. So that would be leaving the y squareds as part of this. And so that's just choice A. And that is the answer. Like I said, I think that's the best way to get this. You need to know this factoring skill for other questions on the test, so it's not like we can avoid it entirely. Plus, it's pretty fast if we know it. And you can always check your answer by distributing back in and just making sure you kind of get what you started with. If you wanted to arithmetize, even if it's just for practice, remember, if they don't tell us to solve for x or y, or it doesn't seem like there's a specific value, then we can probably make the value up. So in this case, the simplest kind of thing I would do is x is 1, y is 1. I wouldn't do 0 here, because thinking ahead, if I made x 0, then all those 5x's and 5x squareds become zeros, and then everything's just going to be 0. So there's going to be no way to tell the choices apart. But 1 has a little bit more of an impact. So if I took the 5x squared minus 50xy squared, and I put in 1s for all those terms, right? So that'd be 5 times 1 squared minus 50 times 1 squared. Well, 1 squared is 1, and so this is the benefit of 1. All the exponents kind of disappear. So 1 squared is 1 times 5 is 5. 1 times 1 squared, that's all a bunch of 1s as well. And then times 50 is just 50. So 5 minus 50 is negative 45. So that's kind of like my magic number. And now I'd be looking for an answer choice that also gave me negative 45. So let's go to choice A. That would be 5 times 1 minus 10 times 1 squared. So yeah, there's a couple steps, but again, the 1s kind of disappear. So this is really 5 times 1 minus 10, which is negative 9, and 5 times negative 9 is negative 45. So that looks good, but if I did choose to arithmetize, I would need to check every choice, because it's possible that multiple answers work. So we have to be careful. I'm going to kind of cut to the chase with these other ones. Choice B would be 5 times 1 minus 50. So that's 5 times negative 49. I'm not even going to bother to put that in my calculator. I know that's way too big, so we'll get rid of that one. This would be 5 times 10, so that's 50. So no, not negative 45. And this is 5 times 50 as well, or 5 times 50. And so that's another big number, 250, right, I think? So that's also gone. So that's how it would work. You would get the answer here with some simple arithmetizing, but you can tell that that's way more work than what I did originally. So the strategies help us in lots of cases. You should look for opportunities to use them even when they might not be super efficient, so that when you get that practice, you're building a skill that you will need in the harder questions. Here, I don't think arithmetize is efficient, but it does the job.